Good day, everyone. So we have number of delayed tests under the scheduling problem. So what is scheduling? Scheduling is the process of prescribing when each operation in a production process is to be executed. According to Campbell and Campbell, scheduling is the determination of time that is required to perform each operation and also the time required to perform the entire series of operations as routed. So other definitions of task scheduling, we have activity or task scheduling problem. This is the dispute of optimally scheduling unit time tasks on a single processor where each job has a deadline and a penalty that necessary be paid if the deadline is missed. So according to this definition, um, task scheduling problem has jobs, deadlines, and also penalties. Okay, so we will learn further with that by um, learning some examples. So a unit time task is a job such as program to be rushed on a computer that needed precisely 1 unit of time to complete. Given a finite set S of unit time tasks, a schedule for S is permutation of S, specifying the order in which to perform this task. The first task on the schedule starts at time 0 and ends at time 1. The second task begins at time 1 and finishes at time 2, and so on. So, the dispute of scheduling time tasks with deadlines and penalties for each processor has the following inputs. So, muna ang mga sulod. So, first is the set S, which has 1, 2, 3 to n of n unit time tasks. Okay, so a set of n integer deadlines. We have deadlines also, and that satisfies di's from 1 up to greater than 1 or greater than or equal to 1 and less than or equal to n. Okay, so if the task is done by its deadline, then that will become our profit. But if the task will not be done on its deadline, then that is incurred as penalty. Okay, so we will learn some examples of task scheduling so that we can understand further about this topic. So example, find the optimal schedule for the following task with given weight or penalties and deadlines. Okay, so this is the given example. So in here we have a table which has 7 tasks. So this one is the number of tasks, while di's is the due time or deadline, and wi is the penalty. So the solution for this is we need to use the greedy algorithm or the greedy approach. So first steps using greedy algorithm or greedy approach is to arrange the penalties or sort all the penalties in decreasing order. So this table is already sorted from the highest penalty to the less penalty. And the next step is to find the maximum value of the deadline. So in here we find out that the maximum deadline is 6. So next step is to make a Gantt chart that represents the task where I is from 1 to 7. So this will be our chart. So imagine that these cells not are not occupied yet. So these are blank cells. Okay. So after that, the next step um, is we need to look at this task which has the highest penalty. So task 1 has a due time of 4. So we look at our chart and find 4. Then we will look backwards, finding an empty cell which we can put this task. Okay, so there are 4 available cells. So we can put task 1 here. So task 2 with 2 deadline 2. So we will look at these 2, then look at backwards. So there are 2 available cell. So we can put a task 2 in this cell. Next is task 3, which has 4. So this one is 4, then look backwards. So there are available cell here, so we can put task 3 here. Task 4 has 3 due time, so this one we look at 3 here and find an available cell over there. So there is also there is this one available cell, so put that task 4 here. Now look at task 5. The deadline is 1. If we look at this one here in our Gantt chart and look backwards, the cell is already occupied by task number 2. So task 5 cannot be performed on time. And next task is task 6, which has 4 due time. So we look at this 4 and then look backwards. So all the cells was already occupied. So task 6 cannot be performed on time. While task 7 has 6 due time. So look at the 6, then look backwards. So there are still available cell here. So we can put task 7 on this cell. Okay, so in here we can see that task 5 and task 6 cannot be accepted after task 7 because their due time is for task 5 is 1 and T6 is 4, which was not done on time. So ma-penalty na sila. So we add the penalty and we can get the total penalty, which is 50. While the total profit or income is this one. It's task which was done on time. So we have task 1, task 2, task 3, task 4, and task 7 with a total of 230. Okay, so the optimal solution for this example is 2, 4, 1, 3, 7, 5, and 6. Looking at this chart over here. Okay, so we will learn more examples. So using also the greedy approach. So we have problem statement here. The problem is to schedule unit time tasks with deadlines and penalties for a single processor. The problem has the following inputs. By the way, the objective function for this is the penalties. We need to minimize the penalties from the constraints, which is the deadlines. Okay, so Um, the same with the example number 1. These are the following inputs. So we'll go directly to the problem or example. Okay, so this one is um, a task or job from A to E. From A to E. Okay, so we have 5 task or job here. So first step is to sort the job in a decreasing order of penalty. So look at the penalty here. It was not already arranged in a decreasing order. So the first step is to arrange that one. So here we arrange the penalties in decreasing order. And after that, we make an empty schedule for the unit jobs. So first, so we have 5 jobs or schedules here. Okay, so after that, we need to find the maximum deadline. So here we have maximum deadline of 3. Then after that, we'll do directly to the task A. Task A has deadline of 2. So look at these 2, then look backwards. So there are still 2 available cells here, so we can plug that task A here, and task C, which has 2 deadline. So here we look at 2, then look backwards again, so we can put that in this available cell. Okay, so this one. So task 3 has 1, and if we look at this one, then look backwards, this cell was already filled or occupied by task C. So task D will not be made in on time. Okay, so also is task B, which has a deadline of 1. So if we look at this one, then look backwards, so na fill na ay na-occupy na ni task C. So CE na 3 na deadline, and if we look at this 3 here and look backwards, so na available cell here, so nga na occupied, so pwede na ito mabutang diya si task A. Okay, so the total penalty will be equal to the sum of the penalties. So we know nga ang mga penalties, this task was not done on time, so matawag na to sila nga penalty, si D and B. So ang sum sa mga penalties is 25 plus 19, which is equal to 34. And the total profit sa mga job nga nahuman nato is job A, job C, and job E. So add that one, so we can have a total profit of 142. Okay, so this one. So ang algorithm sa job scheduling is this: sort all the jobs in decreasing order of profit or penalties, and initialize the result sequence as first job in sorted order. Do the following remaining n-1 job. So mo na itong gibuhat sa atong mga examples. And lastly, the reference. That's all. Thank you.